Welcome back everyone. Today we will talk about change of state. A substance can go through three different states: solid, liquid, and gas. In fact, the substance can switch between different phases. Depending on the process, energy is added or removed. There are a few processes that we need to know. They are melting, boiling, evaporation, freezing, and condensation. Let us focus on melting and freezing. Melting is a process in which a solid changes into a liquid without a change in temperature. Freezing is a process in which a liquid changes into a solid without a change in temperature. When heat is added to a solid, the particles in the solid will start to vibrate more vigorously at their fixed positions. At melting point, the rate at which particles vibrate remains constant, and additional energy is used to break the strong intermolecular bonds between particles. Hence, there is an increase in internal potential energy. Since temperature did not change and remain constant, there is no change in internal kinetic energy. Here are the graphs of temperature against time when a substance undergoes freezing and melting. Do take note that during melting and freezing, the substance undergoes this process under constant temperature. Now let us talk about boiling and condensation. Boiling is the process during which a substance changes from a liquid state to a gaseous state at its boiling point. Condensation is a process during which a substance changes from a gaseous state to a liquid state or gaseous state to solid. When heat is added, water molecules that gained enough kinetic energy break away to be a gas as temperature increases. During boiling, bubbles are formed beneath the surface of the liquid as they have higher pressure than the surrounding liquid and atmospheric pressure. Gas molecules vaporizing from liquid at temperatures above boiling point causes these molecules to exert pressure on the walls. Hence, the liquid exerts vapor pressure. Now, how about evaporation? Evaporation is the process during which a liquid changes to a gas at temperatures below its boiling point. Liquid molecules gather sufficient energy at the surface of the liquid to break away from the solution and become gas molecules. As more fast-moving molecules escape, the liquid will mostly contain molecules with less energy, and hence the average kinetic energy of the liquid falls. The overall energy level of the liquid falls, causing the temperature of the liquid to fall as well. Hence, evaporation causes cooling. There are a few ways to speed up evaporation. We can add in more heat energy, increase surface area, and reduce atmospheric pressure. Now, let us talk about the differences between boiling and evaporation. Boiling is quick whereas evaporation is slow and gradual. In boiling, bubbles are formed and the process occurs throughout the liquid while nothing visible happens, and only takes place on the surface during evaporation. Evaporation takes place at any temperature whereas boiling occurs at boiling point. Boiling requires an energy source while energy for evaporation is supplied for the surroundings. Here is a table to summarize the differences between the two. Difficult to remember? Just remember Rowlett. Rate of process, observation, location of process, energy, and temperature. There are two factors that affect the melting and boiling point. They are impurities and the pressure exerted on the substance. Let us talk about them one by one. A pure substance has only one fixed melting or boiling point. However, an impure substance melts or boils over a range of melting points and boiling points. Impurities lower the melting point compared to a pure substance, but raise the boiling point compared to that of a pure substance. How do impurities affect the melting point of a solid? Impurities disrupt the alignment of the particle in a lattice structure of a solid substance as shown in the diagram below, which weakens the intramolecular bonds between solid particles. Hence, the melting point decreases as lesser thermal energy is required to weaken the forces of attraction between particles. One relevant example is antifreeze. Antifreeze is added to water in a radiator to prevent the freezing of ice, which would potentially cause the radiator to crack due to expansion, since the freezing of ice causes an increase in volume. How about the boiling point? Ionic compounds that act as impurities dissolve in water to form ions. Ions in an impure liquid act as centers of attraction to hold the water molecules from breaking away to form steam, resulting in more thermal energy to overcome the enhanced forces of attractions between the water molecules and the ions. Hence, the boiling point increases due to impurities. Now, how does increasing the pressure affect the melting point? A greater pressure causes the solid structure to break down and becomes liquid. Higher pressure lowers the melting point of the solid. One example are ice skates. When ice is exerted with high pressure, it melts to water and allows skater to easily glide through. However, this is not true for all substances, as not all substances will lower their melting points when pressure increases. For example, when pressure increases on tin or paraffin, their melting point becomes higher instead of lower. Higher pressure means greater energy required for liquid molecules to become gas molecules, as it requires a larger vapor pressure to overcome the atmospheric pressure. Therefore, higher pressure increases the boiling point of a liquid. For example, pressure cookers allow water to boil at 120 degrees Celsius at pressurized conditions, achieving faster cooking with boiling at a higher temperature than the usual 100 degrees Celsius. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye bye.